Welcome to our video tutorial for question 8 of our daily review. Question 8 is asking us about functions, whether or not something is a function, and whether those functions are linear or nonlinear. Now, for this particular question, you're going to see a combination of graphs, tables, and maybe even some equations, and we're going to talk about how we might know if graphs or tables are going to be functions for us. We're also asked if an equation is linear to describe a couple of features of that linear function. In this case, it asks us to find the rate of change, and we also use the word slope to describe the rate of change. And we're also going to be asked to find the initial value, which is sometimes called the starting value or the y-intercept. And we used both of those things in question 7. But if you're not quite sure how to find either the rate of change or the starting value, the initial value, we're going to discuss that in question 9, and so you might want to go there to get some additional help for that. Let's go ahead and first talk about what functions are. Functions are simply a mathematical relationship between input and output values. In this case, sometimes you might hear teachers or even students describe these as math machines. And you kind of think about it like something goes into the math machine and something specific comes out of that math machine. Something is happening in that math machine to make something specific come out for every input value that we have. One of the things that's really important for us to know about all functions is that all functions are going to create a pattern, or they'll show us a pattern, and they are also going to be predictable. And in fact, these two words are going to be words that we come back to many times to make sure that we are determining whether or not something is a function. If it is predictable and if it has a pattern, then it is going to be a function, and if it's not predictable or you don't see a pattern there, it is not a function. Linear functions are simply going to create a straight line when they're graphed. That's pretty self-explanatory. And one thing that's really important for us to know is that all linear equations are actually going to be functions. And we'll see why that is here in just a moment, but you can make some predictions about all linear equations. They will create a predictable pattern, and that is a key for us when we're determining whether or not something is a function. Now, nonlinear equations do not create a straight line when graphed, and unfortunately, there's not an easy rule like for linear equations when we know that all linear equations are functions. Not all nonlinear equations are functions or not functions. So you have to pay extra close attention if you see a nonlinear equation to determine, is it predictable and is it creating a pattern. Let's go ahead and take a look at some graphs. We'll start with our linear equations, and we'll see why all linear equations are functions. So here is my first linear equation. It creates a straight line. This has a positive slope. It's sloping upwards. It has a negative initial value. You can see where the red line crosses the y-intercept, or our vertical line. It's down below 0. And again, if you don't know how to find those specific values of the rate of change or the initial value, refer to question 9 for some additional help with that. Now, when we describe that all linear functions are going to be functions, or all linear equations are going to be functions, that's because they are predictable and they create a pattern. So if I were to think about a future value, oops, I went a little far ahead here. If I were to think about a future value, you can see that I've included a blue line, or a blue dot up there about where a future value might be, or down below, maybe a past value. I could predict where those future or past values are always going to be on any straight line. So that is why our linear equations will always create functions, or they will always be a function. Let's go ahead and take a look at a couple other examples. Again, you could predict where that straight line would be in the future or where it was in the past. And same thing with this one, right? Even though they're going in different directions or at different speeds, we can still make those predictions, or even if I had a line that was going straight across like this. So make sure you're remembering all linear equations are predictable. I can imagine where those lines are going to be in the future or where they were in the past, and that is what makes a linear equation a function. Now let's go ahead and take a look at some nonlinear equation examples. Here is an example that is nonlinear. It does not create a straight line. You're going to see it's a curved line, but we're still going to ask those questions about, is it predictable and is there a pattern? And in this case, I would say yes, it is predictable. I could make a future prediction about where that line is going to be in the future. And maybe even the same thing with this pattern. Right, there is a pattern. I've got kind of an up and a down, and I could imagine the next part. It's starting to go up, and so then it's going to go down again in a minute. So these are predictable patterns. So both of these are functions, even though they are not linear functions. And we'll talk later in the year what types of functions these might be. Now, here's some examples of some things that are on our graph that are not functions. So if I see something like this, I'm going to notice that this is not predictable. There are going to be guesses about where this would go in the future or where it was in the past, right? If I continue on my x-coordinate plane or go backwards on my x-axis, I'm not totally sure where those things are going to end up. So this would be an example of something that's not a function. There's not a predictable outcome for what's happening here in the future. I also have some dots, right? Maybe you see a graph that's got a bunch of dots on it. This is not going to be a function. Not predictable about where those dots are going to appear next or where they would where else they would appear on this. And maybe here's a little step ladder, and this is kind of, we've seen some graphs that look like this on question 7 of our daily review. Well, this kind of looks predictable, but you're going to notice that that predictability actually changes over time, right? And so all of these are examples of things that are not functions. And so if you saw something like this on question 8, you would simply say, nope, not a function, and that's it. Now, let's talk about functions in a table. This is a common way that we're going to see and experience our functions, is going to be in a table. In this case, this is what's known as an input-output table, sometimes known as an XY table, because you can see those values of X and Y. But we're always going to think about, we input an X value and we output or we get a specific Y value. This is kind of like that math machine that's happening. We have some specific values that are coming for every value that we give that math machine. So let's go ahead and fill in my X side. You're going to notice that I just started at 0 and I counted by ones up to 5. The X side being predictable is actually really important. We have to make sure that we're counting by the same number every time in a table to determine whether or not there's a pattern. And we'll actually take a look at this in just a moment. But sometimes if we're not counting by ones on the X side, it can actually look like there's no pattern, but there actually is a pattern, and that pattern is just harder to find because we didn't count by a predictable amount, or we didn't input a predictable value for X. So let's go ahead and start filling out our Y value. In this case, I've got 3 values there that I've given for Y, and you could probably already predict what the next values for Y are going to be, and you can notice what's happening in this particular function. In this case, I'm moving ahead here, and I'm noticing that I'm simply adding 3 every time, right? This is a predictable pattern. For every one value that I put in for X, I'm going to add 3 to the last Y value that I had. So we could continue making predictions. Now, one of the things that you are asked to do, if things are linear equations or linear functions, is to determine the rate of change. Well, in this case, our rate of change was going to be plus 3 each time. That's pretty simple, right? And I said a lot of us probably already predicted that ahead of time. We were also asked to find the initial value, and the initial value is always the value of y when x is 0. So when x was 0 in this, our initial value was also 3. Now I wanted to show this table side by side and describe a couple of things that are happening here that are important for us to check in and understand. Okay, and you might start asking, like, is the table on the right side a function or not a function? And if I'm looking at my output values, I'm going to notice that there's not really a pattern there. However, remember we described that the x values, counting by a common number is really important. In the first example, the example on the left, we counted by 1 each time. And on the right side, you're going to notice that I counted by 1, and then I counted by 6, and then I counted by 2, and then I counted by 5. Because I've counted by a different amount each time, it makes it very difficult to make predictions in this pattern or to identify a pattern. And in fact, if I was to extend my table that's on the left-hand side, you're going to notice that we end up with the same value as we ended up with here. And you could imagine doing that again for number 8 and number 9, and we're going to end up with that same value. Because I know I'm going to add 6 here. We're going to end up with the same values. So these two things are actually exactly the same, okay? But because that x side was not written down in a common pattern or a predictable pattern, it makes that pattern on the y side really, really hard to see. Finally, just as a reminder for us, these are linear equations, and those would create a graph that maybe looked something like that. Let's go ahead and look at another function in an input-output table and see how this might be a little bit different. Again, I'm going to notice that my left side, I'm counting by ones. That makes this a lot simpler for me as I'm working. I'm going to fill in some values on my right-hand side, and I'm going to think about, is there a predictable pattern here? Now, this is a little bit challenging because in our last example, we noticed that it was plus 3 each time. And this one, it starts out as plus 1, and then it's plus 3, and then it's plus 5, and then it's plus 7, and then so my pattern is different. However, there still is a pattern there, okay? And sometimes that's a little bit easier if we write those patterns down. So I'm going to go ahead and write that pattern down. And you might notice the pattern now that it's written down. And there actually is a pattern in this one. So even though this doesn't quite look like a pattern at first glance, it's really important that you're paying attention and you're thinking about what else is going to be there. And in fact, I could guess what my next value would be, and I could guess what my value after that would be following the pattern that is happening in this. So this is another example of a function. This one is not a linear function. In fact, if I were to graph this, it would probably look something like this. This would create one of those curved graphs that we saw. If I were to go backwards, I could still use my patterns of prediction, and it would actually look something like this. So this would be an example of a non-linear function in a table and in a graph. Finally, let's take a look at one more example in a table. Here, I'm going to notice that my x side, I'm still counting by ones, which is a helpful place to start, but I'm going to notice that I am not really seeing a pattern. I plussed 3 when I started, and then I minused 10, and then I plus 12, and then I plus 3 again, and then I minus 23, right? So it's really difficult to find or identify a pattern. And so this would not be a function because there's not a predictable relationship that's happening between the x value and the y value.